Hello, my name is Bruno Pinto, worker in Nectan's company, and I'm here to present a poster entitled Bioremediation of Swine Wastewater using Locally Isolated Microalgae, which is inserted in the project Alga Valor. During the past decades, the exponential growth of the human population has been accompanied by a constant increase of wastewater production. Swine production generates wastewater heavily loaded with nitrogen in the form of ammonia and nitrate, and phosphorus in the form of phosphates. When untreated, the discharge of this wastewater can lead to eutrophication in the nearest water bodies. For this reason, microalgae has been widely used in the field of wastewater treatment, which chlorella and syndesmos present great potential in several articles. Both are two chlorophytes that have been widely used in wastewater treatment studies since it uptakes nutrients from different wastewater sources and since they proliferate in the presence of high ammonia concentrations. For these treatment studies, the production system most used are raceways, since they are ideal for the cultivation of competitive microalgae and have a low operation cost. The objectives of this work are to evaluate the most effective microalgae strain for swine wastewater treatment and to study microalgae industrial potential for the bioremediation of this wastewater. Thus, this study aimed to use microalgae with the best phycoremediation potential for swine wastewater, isolated in the scope of Alga Valor, with a reapplication of the biomass produced as a biofertilizer in agricultural activities. Preliminary trials were made in 3-liter bubble column PBR in order to optimize ammonia concentration using chlorella and afterwards syndesmos, followed by the cultivation of both microalgae in 600 liters raceways, where it was compared the growth of both species. After the pilot trials, the selected strain, chlorella, was scaled up under laboratory conditions later used to inoculate a 100-liter flat panel PBR under outdoor conditions, where the scale-up process continued until a total volume of 2000 liters. With that volume, a 19 cubic meter tubular PBR was inoculated. The full volume of the tubular PBR was used for the inoculation of the 110 cubic meter industrial raceway, together with 5 cubic meter of fresh swine wastewater. Every day was analyzed nutrients from the culture, while biomass was analyzed on the last cultivation day for carbohydrates, lipids, proteins, and ashes. Chlorella was cultivated in an industrial raceway with swine wastewater diluted 1:22. The culture grew in a batch mode for 10 days, followed by a semi-continuous approach for more 17 days, where this last regime was characterized by a renewal of 1000 liters of culture with fresh swine wastewater every other day. Dry weight measurements were performed every day during the trial, and chlorella was successfully grown. Nutrients measurements were made every day, and there is a clear decrease of phosphate and ammonia during batch regime. However, ammonia and nitrate uptake was less evident in the semi-continuous approach. Harvested biomass achieved high percentage of carbohydrates, 48.34%, and proteins, 36.31%, suggesting a great potential as a biofertilizer. Further studies will be done to determine the biomass applicability as a fertilizer ingredient. Thank you. This present work was funded from Alga Valor project with the following reference, and I would like to acknowledge Alga Valor and Nectan for the opportunity and Mar Biotech for the biochemical analysis.